Okay, we've got Joe Beda here. Joe is Pickle Rick. Okay, up next, Ian Coldwater in the same room. Quick shout out to the sponsors. We have Container Solutions, Equinix Metals, Cycloid, Giant Swarm, Instant, and Kinfolk, all of whom are still in the sponsor booths. I'm sorry about the little AV problem we just had there. Joe, you're about to apologize for YAML. Not quite sure if you understand what you're bringing upon yourself. Are you ready?
I'm ready. I'm ready. It's a half an hour apology. We're going to go through it.
Let's do this. Take it away.
All right. Hello, everybody. First of all, for those who don't know who I am, I'm Joe Beda. I'm a principal engineer at VMware working on our Tanzu portfolio of products and services, bringing Kubernetes goodness to enterprises. But I was also one of the co-founders of Kubernetes. And so just want to be clear, the YAML has always been there. I just think that, you know, Kubernetes and YAML in everybody's mind really go together. You know, I don't know if we'd say peanut butter and jelly. Maybe it's like peanut butter and mayonnaise. I'm not sure. But I'm here to apologize. I'll try and explain how it happened. And I don't know if there was a better option, but that's one of the things that I want to explore. So this is a horror show in 3 acts. First, you know, we're going to do a little bit of history of where we got to where we are, how this actually happened. I just want to be clear, this is not an excuse, right? A good apology. You don't try and make excuses, you just own up to it. I'm just trying to document the factors and the forces and everything that really got us to the point that we're at right now. So here's a timeline of YAML in Kubernetes. And it actually starts before we were public with Kubernetes. We had this Python-based agent that was essentially a declarative adapter for Docker at the time. So I don't know if you remember back in like 2014, Docker was very imperative, Docker run, Docker stop, that type of thing. And we wanted to bring the idea of you have a declarative manifest of like, hey, here's what should be running, and then you can take a collection of those, then you have an agent that actually drives Docker to make sure that stuff happens. And so this was creatively called the container agent, and we released it while I was giving a talk at GlueCon in Denver, outside of Denver in Broomfield, in May of 2014. And this is the first this is kind of like the proto-kubelet. This is the kubelet before we had the kubelet. And if I remember correctly, Tim Hawken was the one who actually wrote this. And I don't know if he's the one who came up with using YAML there or what, but, you know, maybe we can blame Tim. He's still, you know, paying for his sins by continuing to be really one of the backbones of open source Kubernetes. And so huge shout out to Tim there. And then finally, in June 2014, we released Kubernetes. And at that point, YAML wasn't totally embedded in it. It was used as a config file for the kubelet, again, carrying forward a lot of the ideas from the container agent. And the command line client that we had at the time, which in the original version of Kubernetes was called Cloud Config, it got renamed to kubeconfig, and then it got renamed again to kubecontrol. It would output YAML, but if you wanted to take a manifest and upload that to the server, it only supported JSON at that time. And then finally, in June 14th, there's this PR from Daniel Smith, Lava Lamp is his GitHub alias, where he actually added the code in the sort of proto-kube control to be able to parse YAML and upload that. And so it supported both YAML and JSON at that point. And I think this is like one of the problems that we introduced at this time is that we could have just done that sort of YAML to JSON conversion, as part of the client side, and then only speak JSON over the wire. But somehow, somewhere, the server started accepting YAML directly, and I think that was probably a mistake. And you'll see, that there were some security issues that we ended up hitting because of that. So this is a little screenshot from that code review for introducing YAML parsing, and I want to zoom in on one line there. This will work for now, though. And this was, wasn't exactly about using YAML, but that was kind of the attitude at the time of like, hey, we're bootstrapping this thing. We got to get it up and running. And let's just, this will work for now. And so I think the big theme here is that it made sense at the time. And like, I'll draw the connection to Pickle Rick here, because if you watch the Rick and Morty episode with Pickle Rick, I think you'll find that, it was not a well thought out plan from Rick's point of view to turn himself into a pickle. So same sort of thing. It's like it made sense at the time in terms of look what we were trying to do. And so at that time when we were bootstrapping Kubernetes, we were really focused on building something that could be built upon. And so from that point of view, the API really was central to how we were thinking about things. And this was really about creating a layered system where we have structured APIs for both end users calling into Kubernetes, but other parts of the Kubernetes systems calling across to each other. So all of our focus was really on that API. And I think it really paid off because, you know, I think one of the things, if you look at the longevity of Kubernetes and the success that it's seen, having a really good set of API patterns to ground things, I think has been one of the keys to the success of the system. But what it means is that I think we became blind to some of the other issues, right? We were focused on the API. We needed a client that made it easy for us to actually talk that API. The easiest thing was to actually take a file on disk and just upload it to the server. And then it's like a pain in the butt to write JSON. And so like the smallest thing we could do is say, hey, let's write a little bit of YAML instead of JSON. And I don't think anybody really did an exhaustive study of all the options at that point. It was really just about, hey, let's make life a little bit easier as we're talking to the API. And, you know, and really it was like kicking the can down the road. We really assumed that there would be time to fix this later, that, you know, if we get a good API, we can build better tooling, better abstractions on top of it. And so, yeah, that wasn't the problem that we were focused on initially. And so that's how YAML became the thing. I don't think anybody intended people to be writing raw YAML, you know, what are we like 6 years later, 6+ years later. There was an assumption that we would find the right way to do it and be able to sort of like make YAML just be a detail. But we haven't actually found a single, you know, solution to this problem, and I think there's a bunch of factors for that. So I'm not even sure that there is a single solution that actually would replace YAML to some degree. I think there's definitely problems to be solved, but there are some fundamental hard problems here that I don't think that there's a single solution. All right, so moving on to the second act here, ghosts of the present. So within the hatred of YAML, there are two wolves. Now, I know this picture here has 3 wolves. It was royalty free, and ignore that wolf on the right because that's Bob, and nobody likes Bob. He's like the black sheep of the family. And if you think it's bad being a black sheep of a human family, imagine being a black sheep of a wolf family because they like eat sheep. But okay, ignoring Bob, there's 2 wolves inside of the hatred for YAML. The first of these things is YAML itself, right? This is white spacing, some of the sort of overly wrought semantics and sort of esoteric features that can be confusing. The fact that it's very, very difficult to template, especially with something like Go templates as Helm uses it. A lot of that frustration with just the format itself. The second frustration is the problem that YAML's trying to solve and the underlying complexity of the configuration of the system that's trying to be configured. And a lot of those complaints, a lot of those frustrations would really apply regardless of what format you're using. So like to some degree for those set of issues, I think YAML is maybe being unnecessarily maligned. Not that there's not enough to bitch about YAML itself. So let's start with Whitespace. I think, you know, Whitespace is a love it or hate it type of thing. It can sometimes be very easy to read, but the combination of Whitespace plus Kubernetes being relatively deeply nested in terms of its format means that without a lot of great tooling, it's very easy to get things misaligned, and that can be a real source of frustration. Especially if you don't have tools to help you check the schema and make sure that you're not making a dumb mistake in terms of indentation. So that I think is, you know, fundamentally a problem. I would, I think if JSON had comments and didn't, you know, wasn't quite so persnickety about quoting, I think we probably would have never actually gone to YAML. Now this I think is actually probably a more critical problem here, and this is, you know, what we'll call the Norway problem with YAML. And so I don't know if you all have seen this, but YAML is very liberal in terms of doing type conversions. So if something looks like a number, it'll interpret it as a number. If something looks like true or false, it'll actually, the serializers as you bring these things in, will interpret those things as a Boolean, as true or false. Now the problem is that let's say you have a YAML file with a whole list of country codes, and because YAML doesn't enforce quoting, what happens is that you have US, you have UK, you have all your country codes. It all works great. I started at the U's apparently, and and then eventually you get to Norway, and the abbreviation, the country code for Norway is NO, and YAML's like, oh, that means false. And so as you're importing things, what'll happen is that you'll end up with a mixed list in your, as you deserialize this with strings and then like false out of nowhere. And oftentimes, especially if you're using a dynamic language to process these things, this will actually result in a runtime error because you'll be expecting a string and you'll end up getting a Boolean and hilarity ensues. Oftentimes, this may be caught earlier with schema validation, but that's not something that's necessarily always common or commonly enforced. There's similar issues around type coercion with respect to numbers, for example, right? So if you have a number that's like 1.3.0, which is a version, YAML will interpret that as a string. But if you change that slightly and you just make it 1.3, all of a sudden YAML interprets that as a floating point value. And so that also creates confusion in terms of actually type coercion. And so, yeah, that is, I think, one of the hardest problems with YAML. And then finally, YAML actually has a fairly large attack surface. I think there's two great examples here. So the first one is that there's an attack on YAML around, essentially YAML has this feature of being able to do references where you can have a piece of structure reference another structure, and you can reference it multiple times. And when you go to actually expand that out into something like JSON at the parsing level, it ends up, being very, very easy to create a small piece of YAML that, when fully expanded, uses a boatload of memory inside of a program. And so there was actually a CVE in Kubernetes around that, where you could take a very small snippet of YAML, and it's kind of like a zip bomb, where you can give this to the server, and then it ends up being a denial of service attack on the server because the server ends up eating all its memory as it looks to expand that. And so this is where I think having the server ever accept YAML was probably a mistake. We probably should have kept to JSON on the wire, since it is plain old dumb data, whereas YAML, it gets a little bit too fancy for its own good in a lot of ways. And then there's other situations, and we haven't seen this specifically in Kubernetes, but that type coercion that we talk about, there's also semantics where you can actually specify the runtime type that you want this thing to be serialized in. And so if you take untrusted YAML data and you deserialize it and you don't put any guardrails around it, you may end up creating objects inside of your program that you didn't think that YAML was going to be able to create. And so this can have some really interesting side effects. And there's some examples of remote code execution vulnerabilities due to Ruby using YAML and enabling this sort of, type instantiation features that come with it. All right, so now let's get into some of the problems that we see with Kubernetes. These are problems, with Kubernetes, but people usually view these things through the lens of YAML, and so they often blame YAML for these problems. So the first thing is that, a lot of folks look at Kubernetes and say, oh, it's too verbose and it's too complex, that format itself. And I think this, again, comes back to the idea that we were building something that was fundamentally an API that we wanted to make work for machine-to-machine communication. And when you're actually talking across services from machine to machine, you end up with, a lot of explicitness. Explicitness in that case can actually be a virtue, because it means that there's not a lot of assumptions to work with, and it becomes a lot easier to know exactly what you're talking about as you communicate between machines. But that same explicitness that makes so much sense for machine to machine really works against you when you're a human. So there's a lot of examples in Kubernetes where, you may go through, and if you're specifying, say, a deployment, you have to specify a set of labels on the deployment itself. You have to specify essentially a selector that also specifies a set of labels, and then the template for the pod that you're creating also has a set of labels. Oftentimes, if not most times, like probably 90+% of the time, these things will actually line up pretty explicitly. But there are some cases where these things will diverge, and if you're using the YAML in a raw way directly, we really make you take on the complexity of those advanced cases, even when you're trying to do something simple. The next thing is that there's a long tail of features for Kubernetes. There's a lot that Kubernetes can do. Things like that, the cases where you do want to diverge the templates and the labels and the match, the labels on the template versus the match selector. And so that long tail of features really speaks to the power of Kubernetes and that it can solve so many different problems, but it makes it harder to solve some of the easier problems. Now, one of the things that we see, and some of this is I started my career at Microsoft. And so one of the questions at the time was, why is Word, so for example, Microsoft Word, why is it so bloated? It has all these features. I only use 20% of the features in Word. And it's true. Any single person only uses 20% of the features. But the Word team did an analysis, the Office team in general, and I'm probably getting the percentages off, but the lesson still holds, where they found that every user uses about 10% of the features of Word. And then there's a long tail of usage in terms of other users then use a different set of 10% of those features. And so everybody only uses 20%, but it often is a different 20% from other people. Some people will use a lot of the equation formulas in Word. Some people will use change tracking. Some people will use a lot of the desktop publishing stuff. Some people, God help them, use like word art, right, to do like crazy, ugly word stuff. But there's essentially a user for every single one of those features, and there's a reason why it was added to the product. And I think Kubernetes is a lot the same way. You can't point to any individual field in Kubernetes and say we don't need that, because there is somebody who needs that. What you can say is 90% of users don't need that, or most users don't need that, but there still are some cases where those features show up, and those get reflected into YAML and create the overall complexity that I think a lot of people feel when they look to use and configure Kubernetes as a whole. Now, another problem that we have here is delayed errors. And so this comes back to some of the schema validation and the Norway problem in general, is that oftentimes you write something and then you don't find out that it's wrong until much later. And that can be really frustrating because it ends up lengthening your sort of your inner loops, right? You want to be able to discover errors as fast as possible, react to them. And if you have to do something, that stretches across lots of systems and takes you 10 minutes, it's going to be much less efficient to be able to deal with those errors. And so there is some work in Kubernetes to do, client-side schema validation, and you can do dry run type of stuff. So there's work to be able to deal with this, and there's tooling like extensions to VS Code. But I think there is a lot of frustration that when you're writing YAML, it's like a dynamic language, where a lot of times you won't see those errors up front. You're only going to see them at runtime, and it may be at a very inconvenient time. And then finally, I think that, there's this whole idea of like, I'm a principal YAML engineer. And, we didn't start this career so that we could muck with config files. It's like, work with computers, they said. It'll be fun and engaging, they said. And like, we find out that we're spending all of our time dealing with these fiddly little config files. Now, these things are powerful, they're important, but like, we became programmers so that we could program. And so I think that there's a lot of fatigue with just mucking with these config files in general. And you'll see this across a lot of systems. Like, you talk to a Java programmer and they're probably sick, or .NET back in the day, they're sick of dealing with XML config files for dealing with configuring their middleware, right? So this is not a new problem. And I think what we're finding is that, as we start seeing the overlap and the merging of ops, a lot of what operations is configuration of systems. And so as we start seeing these roles start to overlap, I think we're seeing the reality that so many folks in an operationally focused role deal with gets bubbled up into much more of the developer role. But it also means that the set of audiences across Kubernetes really stretches from folks who are comfortable editing YAML files all the way to folks who are like, hey, you know what, I'm going to write C++ to generate my YAML or to generate my config. And so, when we look at Kubernetes, we see that the user base stretches across that entire spectrum. All right, so now on to our third act here, ghosts of the future. How do we fix this problem? So the first thing here, and I've come to this conclusion after taking multiple runs at this particular windmill, is that there are no silver bullets here. And here we have a little angel trying to spear, I don't know if you can see this, trying to spear a wolf, right? So we're bringing the wolf theme in here. There are no silver bullets. I think, talking about the best way to manage config in Kubernetes is really kind of similar in some ways to asking somebody, what is the best, programming language? I mean, folks have opinions, but I think at the end of the day, we know that there are different tools that work well in different situations. And I think recognizing that we're not going to find a one-size-fits-all solution to this is probably the first step to coming to grips with the world that we've created. And I think this comes down to, like, if we had focused on this originally with Kubernetes, I think it would have probably been a very different product, and we might not have had the success in the applicability across so many domains, because that view of the config language might have constrained the set of problems that we approached and were able to solve. There is a theory here of let 1,000 flowers bloom, and I think, Brian Grant for a while kept a spreadsheet. I found it and looked at it, but I don't think he's updated it recently, that enumerated essentially all of the YAML wrangling tools. And there are a lot, and it's growing, and I don't think it's going to stop anytime soon. Like the rest of the cloud native, ecosystem, this is sort of a beautiful chaos, right? I think there's a lot of really great ideas being tried out here, and there's a lot of really interesting stuff being done. And I definitely have, my favorites in terms of the set of YAML wrangling tools that I've played with. And I think it's a really interesting area, just like programming languages. But I think we're all poorer because we don't actually have that 90% solution. And so I think that's a problem. I'm not sure how we solve that at this point, because there are a lot of great ideas out there, and there really is no fundamental forcing function to try and get everybody to converge on a single solution for this problem. So some of the trade-offs that we need to think about here as you're looking at your YAML wrangling tools here. Do you want to think about this as code, or do you want to think about this as config? And so this is the, so there's this blog post from 2012 from, I believe it, Mike Hadlow. I got the link in my notes here. You can just Google it, called the Configuration Complexity Clock. And I believe that there's been other talks about this in the past, but it's this idea that there is this cycle that we enter where we start with a simple DSL for solving our problems. And as we understand our problem space better, and as things get more complex, we end up adding more and more features to our DSL until at some point it turns into, it wakes up and takes over the nuclear missiles, and, and all of a sudden we're living in Terminator. No, it becomes Turing complete. And what we end up doing is sort of reinventing a computer language, but in a crazy way, right? And so this is and so the line between, hey, this is just plain old config and this is code, is a really, fuzzy line. And so you'll see some approaches that are like, let's keep it as plain old config as possible. And you'll see other approaches that really lean into the Turing complete nature and say, well, we're going to end up with a language anyways. We might as well just support a real language that supports testing and toolability and all the other things that you want to get with it. But I don't think that there's a real answer here, because like I said, the set of audiences for folks who interact with Kubernetes stretches everything from folks that, really are comfortable editing YAML files or some other type of config file, all the way to programmers who really just want to write code because that's the world that they live in. Should this be Kubernetes as specific or abstract? I think oftentimes people are like, well, as long as I'm creating a higher level system, why don't I make it work with Kubernetes or some other native cloud system or what have you? And oftentimes, in my experience, this really becomes a sort of lowest common denominator thing, and fundamentally, you end up with leaky abstractions. The underlying platform has to find its way through, because it just turns out that the things that you need to do need to take advantage of some of the special abilities of the underlying system. Another way to look at this is like, do you embrace concepts or do you hide concepts? And this is really related to the other one, but that one was about whether you target beyond Kubernetes. But here it's like, do you try and create a simpler Kubernetes here? And so, an example here is that, we have like replica set and deployment, service and ingress. All of these things are separate concepts and objects. Do we try and combine all of these things into one concept? If we do so, will we be able to hit all the scenarios, all the use cases that we need? And I think one of the things that we see is that within a narrow framework, if I talk to an enterprise and they have, like, they understand their users, oftentimes they can see a lot of success with coming up with a much simplified deployment manifest of what they want to do. The problem, though, is, again, just like the word users and the long tail of features, what works for them and the subset of features that they need and the way that they put them together isn't going to apply to everybody. And so we see over time, if you try and make these systems be generally applicable, that you add more and more features and you end up reinventing the full Kubernetes model, but you're doing it in this sort of ad hoc filtered way. And so I think within a narrow confines, hiding concepts makes sense, but I don't think you can do it for everybody. It's fundamentally going to come back down to that sort of, there is no silver bullet, there is no one size fits all. And then, do you do this client side or server side? I think with the advent of operators and controllers with Kubernetes, there's a lot of opportunity for us to actually be able to split across these different domains. And so, this helps us avoid what I like to call the magic laptop scenario. This idea where you have a bunch of config on your laptop, you start a process, if you close the laptop or if the laptop gets lost, you're kind of out of luck. If we move this stuff server-side, it gets more complex because you have to write server-side components, but fundamentally it's easier to share these things. And then finally, the last thing here is I really want to take a tool chain mindset here. I think that there is no silver bullet for wrangling YAML, but I do think that we can take the problem that we want to do, break it down into smaller chunks and be able to compose these things together. So what this means is that if you have one way of templating, one way of tracking dependencies, one way of applying these things, can we take a Unix philosophy and break these things into separate tools? As we start intersecting with things like GitOps, I love the work that's happening with the GitOps toolkit. Can we actually then be able to provide the pieces so that folks can take this plumbing, put it together in a way that makes sense to them? And if they don't like one piece of the puzzle or it doesn't work for them, they can go ahead and replace that, but there's still a lot of shared context and commonality that we're building across. So this is, I think, not the solution, but it's an approach here to really be thinking about this as a set of smaller tools that have cleaner interfaces versus a overriding solution to this problem space. So with that, thank you. I really appreciate you listening to me go on for about a half an hour about all the problems with YAML. And again, I just want to be clear, not excuses. I'm sorry. I didn't mean to foist this on the world. It really seemed like a good idea at the time. Thank you.
Joe, thank you so much. We're a little over time, so we don't have time for questions. One observation, I was wondering the whole time, what's that background noise? And I realized it's the fan keeping your suit
sorry.
That's what it is.
It was this mic so that I could mic myself up inside of Pickle Rick.
No. It was very much in the background. There were a few questions, but I'm sure people know where to find you on Twitter.
Hit me up on Twitter.
Mainly people were asking if you could breathe. The fact that you got through it suggests that you could.
It is getting a little warm in here, I'll be honest.
Okay. Well, we're going to let you go now then. Joe, thank you so much for that.
Thank you, everybody.
Up next, we're going into the Software Circus TV. That's track 3, Spooky Cocktails, for 10 minutes. 10 minutes back here for the last talk of the day, Ian Coldwater with Into the Bramble Forest, What Lurks Within, and What Happens When You Find It. See you back here in 10 minutes. Bye-bye.